Hi guys, welcome to our lesson on cardiovascular reflexes, regulation of arterial blood pressure. I'll start off with this question here for you, just to sort of like bring you back to one of the earlier points that I made. I'm going to bring it back later on. It's fairly relevant. What is the primary determinant of cardiac output? Stroke volume, mean arterial pressure, total peripheral resistance, and heart rate. And the answer is heart rate. Your body, first of all, it does not regulate change arterial pressure in order to change cardiac output, ever. It does not change total peripheral resistance in order to change cardiac output. It changes stroke volume and heart rate, and of the two, heart rate is the one with the biggest dynamic range, and it's the one where changes have the biggest effect on cardiac output. So your mean arterial pressure is regulated. It is regulated, as I said, by changing this, this, and this. And cardiac output and total peripheral resistance vary short term. Blood volume varies long term, and this will be a big part of the renal section, the vital fluids. So if we're going to talk about reflexes, we need to talk about the brain, although I don't like talking about it too much because I'm far from an expert, and you guys will get a whole block focusing on the central nervous system. The cardiovascular control center is located in the medulla of your brain. There are a large number, there's the medulla. There are a large number of sensory inputs, including the cortex, which of course makes you blush. The hypothalamus receives inputs having to do with temperature, and it can be involved in terms of the brain, but pretty much for the most part, it all flows into the medulla and then out from there. Of course, we have a variety of different stretch receptors and baroreceptors, chemoreceptors, things like that. Okay, that feed in here as well. All right. So pretty much all of this eventually feeds into the cardiovascular center and then out from there. Okay. The primary sensory inputs that we are going to focus upon in this lesson are the baroreceptors, which are responsible for initiating a baroreflex, and the volume receptors, which I will talk about late in the lesson. They initiate a reflex of their own. Okay? So, let's talk about the baroreflex and what happens when mean arterial pressure drops, and that is demonstrated in this figure here. So the first thing that happens is the decrease in pressure is detected either at the baroreceptors in your carotids, which feed into your cardiovascular centers through the sinus nerve, which I believe is the 9th cranial nerve. And also you get some detection at the aortic mechanoreceptors, the aortic baroreceptors. Their input goes in through the vagus nerve. This is way more important in animals. This is more important in man and apes, probably because we walk upright. Okay. In either case, you get the inputs into the cardiovascular centers. Your cardiovascular center processes it, and it increases sympathetic outflow. Okay. And it decreases parasympathetic outflow. That is primarily through the vagus. Of course, the sympathetics flow out of the spinal cord through the sympathetic ganglia and out. And so the biggest output for the parasympathetics in terms of what we're talking about is the vagus nerve, cranial nerve 10. Okay. The combination of those two, both sides innervate the SA node, and they increase heart rate. The sympathetic side innervates the ventricular muscle. Both sides innervate atrial muscle, and you get an increase in contractility due to this action as well. Okay. In addition, this increases cardiac output. The resistance vessels, renal, splenic, skin, so on, muscle beds, they constrict and increase the total peripheral resistance, as you see, sort of down here, okay? And you also get stiffening of the walls and the veins, so they hold less blood at the same pressure, and the blood that was in there exits and becomes circulating blood flow. That helps increase the mean arterial pressure as well. And I just said that, okay? It increases the blood volume, all right? So that's your barrel reflex. In a nutshell, increased cardiac output, increased total peripheral resistance, increased mean arterial pressure, back up toward normal, okay? The baroreceptor is reflex is a negative feedback system, which means that you get a drop in blood pressure that sends fewer impulses to the brain. The brain outputs in such a way that you increase sympathetic tone and decrease parasympathetic tone, and that brings pressure back up. So it's a negative feedback system with mean arterial pressure being the regulated variable. Okay? That's all I've got for this video. Thank you for your attention, and when you're ready, we'll go to the next video where we describe this barrel reflex in a lot more detail.